Hello, viewers. Welcome to another edition of Ekele's Online Mathematics. Today we're going to be looking at the topic indices, a very popular topic. What is indices? Indices is the plural form of the word index. That is the first thing you need to know. Then the mathematical definition of indices is this. The index of a number n to a particular exponent x is the number of times n will multiply x to give y. I repeat, the index x of a number n is the number of times x will multiply n to give y. Now, this is a simple mathematical definition of indices. Indices has certain laws. We are going to use the laws to solve problems. Now, time will not permit us to begin to write all the laws, but these are few laws of indices. The first law is called the product law, that says a raised to the power of x multiplied by a raised to the power of y equal to a raised to the power of x plus y. The second law is called the division law, that says a raised to the power of x divided by a raised to the power of y equal to a raised to the power of x minus y. Then there's another law that is called the zero law, that says a raised to the power of 0 is 1. Another law is the reciprocal law. The reciprocal law says a over b raised to the power of negative x equal to, interchange the numerator and the denominator, you have b over a, the negative power will dematerialize into a positive power. This fourth law is called the reciprocal law of indices. There is another law that is called the fractional index law. This law says a raised to the power of x over y is equal to y, the square root of a raised to the power of x, etc. There are other laws of indices, but time will not permit us to begin to write all the laws. As we solve problems, we shall be using the laws in problem solving. Now let's look at an example that says evaluate the square root of 54 a raised to the power of 5 b over 6a b raised to the power of 3. Now let's evaluate this. Let's evaluate this. Solution. The first step to solving this problem, you rewrite the question. 54a raised to the power of 5b over 6a b raised to the power of 3. Now here is the question. Now this question is complex. The first thing to do is to simplify the question. 54 divided by 6 is 9. A raised to the power of 5 divided by a is a raised to the power of 4. You have b divided by b raised to the power of 3. You have 1 over b raised to the power of 2. This is how you have it. Then the next thing is to look for the square root of what is here. Then the square root of 9 is 3. The square root of a raised to the power of 4 is a raised to the power of 2. The square root of 1 is 1. The square root of b raised to the power of 2 is b. This becomes your final answer. You have succeeded in simplifying this complex number into a simpler number by the principle of indices. Let's look at another example that says if, okay, let me clean the board and continue. Another example says if x raised to the power of 3 is equal to 0.000001, find x. Here is another example on the concept of indices again. Then let's solve this. solution, you have x raised to the power of 3 is equal to 0.0000001. What do? You can see we have decimal numbers. The first thing is to change the decimal part on the right-hand side of the equation into fraction. If you do that, you have x raised to the power of 3 equal to 1 over, how many digits? 1, 2, 3, 4, 5, 6. That's 6 zeros. 1, 2, 3, 4, 5, 6. This is 1 million. Now you have changed the decimal to fraction. The next thing is to change the fraction into a standard form. You have it this way: x raised to the power of 3 equal to 1 over 10 raised to the power of how many zeros? 6 zeros. 1 over 10 raised to the power of 6. Then the next thing to do is to look for the cube root of x. X becomes the cube root of 1 over 10 raised to the power of 6. X becomes the cube root of 1 is 1. The cube root of 10 raised to the power of 6 is 10 raised to the power of 2. We continue from here. Then x becomes 1 over 10 raised to the power of 2 is 100. That is 10 times 10, 100. This is your answer in fraction. If you want your answer in decimal, it will be 0.01 in decimal. This becomes the final answer. There are many other complex examples on the subject of indices, but we're going to stop here for now. Please don't forget to like and share the video. Thank you.